Good morning everyone. I am very glad to share my topic with you. Then today I'd like to talk something about regression testing of massively multiplayer online role-playing games. Regression testing aims to check the functionality consistency during software evolution. Although general regression testing has been extensively studied, regression testing in the context of video games, especially MMORPGs, is largely untouched so far. In this work, we propose a reinforcement learning-based regression testing technique that explores differential behaviors between multiple versions of an MMORPG such that the potential regression bugs could be detected. Table summarizes the information about the statistics of 3 large-scale industrial MMORPGs, Justice, Revelation, Ghost. We can see that the industrial games are often quite complex in terms of game content and update frequency. Meanwhile, the fast evolution of industrial MMORPGs brings several challenges for regression testing. First, the game space is huge. Existing testing techniques are often hard to generate valid test cases, making the game testing largely rely on the manual play or written scripts, where scripts can also often become unusable when the game is updated. Second, existing white box testing techniques could capture the software differential behaviors, but they can be difficult to be applied for game testing. They are often not scalable in the complex MMORPGs, and some relevant states or randomness in MMORPGs could only be triggered at runtime. Third, moreover, for confidentiality reasons, most company has strict control over the access of the source code, which testers often do not have permission to access. Thus, the game testing process is mostly black box. Fourth, game updates are rather frequent and require efficient methods for testing the change. The regression testing is still a pain point, leaving the released game under risks in some cases. Fully automated regression testing of games is highly demanding. So, we need a new solution to deal with these simple and plot-oriented quests. In this work, we propose a reinforcement learning-based regression testing technique for MMORPGs, aiming at effectively exploring the changes of 2 versions of the MMORPG. Game playing could be well modeled as a Markov decision process. At each discrete time step, the agent observes the current state and chooses an action. After the execution of action, the game environment is updated to a new state. A reward with regards to a specific goal is calculated for the current action at current state. The process continues until the agent finishes the given task. An MMORPG often provides a large set of game information, which is high-dimensional and noisy. Following the human experience in game playing, we design a denoising strategy to collect the key information from the raw data, which includes 3 key steps. The 3 steps are omitting task-irrelevant information with some domain knowledge, reducing dimensions by transforming feature expression and performing the interval abstraction to discretize values. After the process of the denoising, we obtain low-dimensional information, which is concise and still contains useful information. Moreover, in general, the goal of regression testing is to explore more divergent behaviors between 2 versions. To achieve this goal, the policy at least needs to accomplish the complex task such that deep states can be covered. And, the policy needs to explore more diverse behaviors of the game such that more divergent behaviors are more likely to be reached. We propose a multi-reward fusion method that considers the task accomplishment reward, the diversity reward and the divergence exploration reward. The equations of these 3 rewards are shown. To demonstrate the potential of our method, we select one task from a commercial MMORPG as our target and 4 baselines to perform the comparative study. The baselines are random strategy, accomplishment strategy, accomplishment and diversity strategy and accomplishment and diversity and divergence strategy, respectively. In the experiment, we use 3 metrics for measurement. The preliminary results demonstrated its potential in capturing differential states and regression bugs. Our technique also has the potential to generalize to a wide range of applications that intrinsically requires complex interactions.